In this use case, we are moving towards the optimization of a brand new pasteurization unit. This heat treatment consists of two lines, line 1 and line 2. And so far, an important anomaly that is causing long downtimes has been detected. When line 1 is running and line 2 starts up, there's a sudden shutdown in line 1. So what are the challenges that we have to face in order to solve that? That we have a brand new unit, this is the first one, so there's a lack of knowledge about the process, about it. The most important one is that we have sudden unexpected shutdowns that we need to troubleshoot. We have to detect the root cause of that. And finally, once we detect the anomaly, the root cause, we will need to follow up the process performance and anomalies detected. So we'll need to create a dashboard with the main KPIs to follow it up at a glance. So welcome everyone to this demo where I'm going to show you how to optimize and leverage your process. In this case, focusing on a pasteurization unit, on a new pasteurization unit that is being implemented in our process. So here we have the main dashboard that is going to be the starting point for our analysis and to follow up our process itself. So here we have for every single line, the main variables of interest, limits that we have to overcome, counting different anomalies, and check the corrective and preventive maintenance events that our maintenance team is taking. Here the status of every single line, and here, really important, this new variable that is being created within TreMiner, combining different variables available in our process to check, for example, to determine what is the total yield or throughput of our process. And now we can monitor it. So this is created within TreMiner, and it's really important. But maybe the first thing that calls our attention in this dashboard is the 5 anomalies that we have for line 1. So we have to immediately start our analysis on these 5 anomalies and check what is the root cause of that. For that, we click here, and we have the 5 anomalies here gathered in a table. We can check, for example, this one, and we see a comment here left by our operators that pressure could be involved. So we just have to click on options and start to visualize to do our analysis. So now we can navigate through our asset framework, asset structure here. So we want to visualize for that period in line 1 the flow rate, pressure, and the status. And for line 2, maybe the status too, just in case it's correlated. We can visualize. And here is the anomaly, this orange bubble. So we can zoom in around the period of interest here. For example, like that. We can zoom in. And we see here that when line 1 is running, this is operating normally, and we start up line 2, there's a pressure drop in line 1, but it seems to be normal since there is no anomaly here. But then when we try to, when the line 1 tries to recover its previous value, it's not able to do it, and here there's a shutdown. That is the anomaly that we have detected, and we want to determine whose root cause it is. So for that, we are going to use our similarity search, so our pattern recognition engine, to look for similar periods in the past that maybe have the same conditions, but we especially want to focus on this period here, on this first pressure drop. We want to add a certain weight or importance to check if all the pressure drops are leading to a shutdown or not. So we can reduce this score to 60 and search. So we have 13 results, one's more correlated and other less. So we can, for example, add one layer that is correlated. So here we have that this is indeed a new shutdown, so it has the same profile. But if we add one period that is less correlated, let's see what happens, or 2. So here we have 2 periods that they are good periods with good productions, where we have this pressure drop, but it's not leading to a shutdown. So after sharing this report to our maintenance team and have a talk, we discovered that this is because of a safety condition. When our pressure in line 1 is below 1.5 during 3 or 4 minutes, we have an automatic shutdown of the line 1. And this is why we are having this event. So we can see that for good periods, the peak is is not that lower, so it's 1.6, 1.7, and we recover the value. But what is the root cause behind it? Why do we have higher or lower peaks here? So the answer is also here in this chart. Before starting up line 2, the pressure in line 1 is around 4 bars, 3.89 for good periods, and around 3 or even less for bad periods. So what we need is a higher pressure here around 4 bars in line 1 before starting up line 2. So this is what we have to monitor, this early indicator, this pressure in line 1 before starting up line 2. So for that, I want to monitor here. So I'm going to create a new search, a new value-based search to check what I want to monitor. So I want to check when my line 1 is running. So it's on. When my line 2 is off. So we have not a startup line 2 yet. And our flow rate in line 1 is lower than 3.5, for example. So this is indicating that we have risk of shutdown for at least 10 minutes, for example. We can search, but we have to save the search and call it preventive monitor, for example. I can save it. And once I saved my conditions that have to be, or that we have to avoid to be met in our process, we can enable a monitor here. Enable a new monitor based on that search. There is this one. Sorry, this one. Select the item, and I don't have to fill this option for now. I just gonna enable the monitor, and just to show you how it looks like here in the dashboard and how easy it's to add here a new tile, a new window to monitor it. I'm gonna do it quickly here. Add a new tile, a new monitor that is indicating us the risk of shutdown that we are having. So for that, we have to select the monitor that we have already enabled. And when it is triggered, when the conditions are met, we're going to say that we are under risk. And if not, there is no risk. And that's all that we have to do to enable a new monitor based on the root cause analysis that we have done before. So right now we have no risk. And this is how this dashboard could be completed with all the variables, anomalies, and the monitors that are coming from the previous root cause analysis that we have done in a few minutes with ShowMiner, and that really help us to do it. So to summarize the demo, the necessary steps that we had to take in order to face the problem were, first of all, visualize the anomaly of interest. Then we use pattern recognition engine to display similar patterns that occurred in the past. And with that, we could compare normal behavior to the anomaly, determining what the root cause was. So everything leads us to the results, where we are saying that the shutdown is due to the safety condition of the pump, that it could also be avoided by increasing the pressure value in line 1 to 4 bars, and of course a preventive monitor was set up and included in the main dashboard where we can follow up the process performance at a glance. So if we talk about value, it has been an increase of throughput by 1 to 2%. It's causing also reductions of 5.4% of waste and savings of around 38,000 euros per year.